Hi guys, so in this tutorial, we will discuss about the intermolecular forces. So, for a brief explanation or a small recap for those of you who might already know this, intermolecular forces mediate interaction within molecules, or it is a repulsion that exists between neighboring particles. So when we say intermolecular forces, these are the things that cause molecules to stick together. That's why your cup of coffee remains as a cup and do not spill or throw away your coffee inside of it, because there is a force within those tiny particles that build or create the figure of your cup. Also, there is a big difference between intermolecular forces and intramolecular forces. So, like what we have discussed in the previous tutorial, intramolecular forces are the forces that hold atoms within a molecule, and there are three common types of chemical bonds within it, such as the covalent bond, ionic bond, and metallic bond. On the other hand, the intermolecular forces exist between the molecules, or it holds two covalent molecules to one another. It is known that intramolecular forces are much stronger enough than the intermolecular forces because they involve the actual sharing of electrons for covalent bonds. By the illustration or image shown on your screens, we can compare the relation of intermolecular forces and intramolecular forces. As usual, it is known that opposite things attracts. That's why there are two pairs of dogs and cats in the image. So, the intramolecular forces can be classified in this picture as the arms of both animals that makes them stick together, or like cuddling at some point. And the arrow that connects both animal pairs can be compared to the intermolecular forces since it holds at least a pair of molecules by its known force. So, before we start discussing intermolecular forces, we need to know first a definition of polarity since it is very essential in knowing the type of intermolecular force given. Polarity is a separation of electric charge leading to a molecule or its chemical groups having an electric dipole moment with a negatively charged end and a positively charged end. Polar molecules must contain polar bonds due to a difference in electronegativity between the bonded atoms. In relation to intermolecular forces, knowing the difference between polar and nonpolar molecules is very important. Polar molecule is a molecule that either containing lone pairs of electrons on a central atom or having atoms having different electronegativities. A nonpolar molecule is a molecule that has identical bonded elements all around the central atoms with no unshared pair of electrons. Also, polar molecule is symmetric and nonpolar molecule is symmetric. So now that we know the polarity, intermolecular forces have 6 different types and we will discuss it one by one. Dipole-dipole. Dipole-dipole is a force that occurs when the partially positively charged part of a molecule interacts with a partially negatively charged part of another molecule. It is commonly consisting of two polar molecules. One of its examples is the acetone or CH2O, wherein it is polar to polar interaction because two acetone has atoms with different electronegativities. So next we have dipole-induced dipole. It is like dipole-dipole, but the difference is dipole-induced dipole has one polar molecule and nonpolar molecule which involve in the interaction. If carbon dioxide and water is combined or have interacted with one another, it needs a dipole-induced dipole force to hold the molecules because water is a polar molecule and CO2 is a nonpolar molecule. Ion dipole. Ion dipole is an attractive force that results from the electrostatic attraction between an ion or ionic compound and a neutral molecule that has a dipole. So simply, it is an ion combined with a polar molecule. For example, when table salt is dissolved into water, the intermolecular force applied is an ion dipole force because NaCl is an ionic compound and water is known to be as a polar molecule. Simple as that. So now let's move on to ion-induced dipole. Ion-induced dipole is a weak attraction that results when the approach of an ion induces a dipole in an atom or in a nonpolar molecule by disturbing the arrangement of electrons in the nonpolar species, or simply an ion combined with a nonpolar molecule. An example of this is when methane and bromide interacts with one another. Hydrogen bond. Hydrogen bond is a special type of dipole-dipole interaction that exists in a polar molecules that contain an hydrogen atom covalently bonded to highly electronegative atoms such as fluorine, nitrogen, and oxygen. One of its examples is the hydrogen fluoride, where hydrogen was combined with the fluorine. Another example, the 4 nucleobases in DNA and RNA such as cytosine, guanine, adenine, and thymine are also consisting of a hydrogen bond. London dispersion. London dispersion is the weakest intermolecular force among all. It is evident in all molecules in either polar and nonpolar, and it is sometimes called as induced dipole. Since it is evident in all molecular bonds, 2 nonpolar interaction is the only remaining interaction that can be classified as London dispersion force since it has no specific term to be called upon. Since we have still enough bonus time, let's discuss in 30 seconds the properties of liquid. There are 4 main properties of liquid. Surface tension is the tendency of liquid surfaces to shrink into surface area. Viscosity, on the other hand, is the resistance of fluid to deformation, also called as thickness. Vapor pressure is caused by evaporation of liquid, and its equilibrium defines the liquid's evaporation rate. Boiling point is the temperature at which the vapor pressure of the liquid is equal to standard pressure. That's the 30-second bonus time. Before we end, let's have first the knowledge assessment. Feel free to pause the video to answer. Okay, let's start answering. For number 1, the answer is ion dipole. For number 2 is hydrogen bond. For number 3 is dipole-dipole. For number 4, it's London dispersion force. And for number 5, we have dipole-induced dipole. Okay friends, that's it. Thank you so much for watching, and I hope to see you again in my next tutorial. Peace out.